Ken Pyle. We're at Connections at CTIA, and we ran into old friend Rob Riordan of Cellcom and Insight. Rob, you've been talking a lot about small cells, and I think that's a big topic of conversation here, and you've been a pioneer in it. Why don't you kind of give us an update of where you see things and where you guys are in the small cell world?
Well, small cells have been around for since 2007. Sprint first rolled out some stuff with it. Verizon has had them for a while. But where it has really taken off now is with the dramatic increase of data capacity needs. It's just insane. And so now we're finding that people are really looking at how do I deload my macro network? Well, think about it. 70% of all traffic happens indoors, either at your house or at your office. A lot of that's your voice traffic. So you're looking at it and say, where do I put it? Now you can go to Wi-Fi, but if I pulled out my Wi-Fi here at the hotel, and I was looking at the meter, and there had to be, I think, a list of 14 different Wi-Fis right where I was. And they were only on 3 channels, so you're in a very heavy contention area. The small cell gives you cellular service. It gives you where you need it. It is controlled. It can't be Charlie's or Fred's. It's the cellular provider's network. And so you know the quality is there. The industry recognizes they need to bring the cell sites closer to the customer, whether it be Wi-Fi or it be a small cell using cellular technology. We're thinking that the cellular technology is going to be huge. Where we're seeing kind of an interesting niche is going over to Korea. We saw KT has both SKT and KT are very aggressive in their rollout of LTE over small cells. What they've done is, give you an example, in the area of small cells using Wi-Fi, they have 200,000, KT does, in the country of Korea. 200,000 of it's actually the enterprise versions. So they're in the Starbucks, they're in the McDonald's, the movie theaters, all of those different places. What they're doing is slowly replacing those with an LTE small cell. Now the LTE small cell goes in, and if they're getting over a certain amount of data, they will put in an LTE small cell. I'm sitting in the Starbucks, and I'm checking the meter to see what kind of speeds we're looking at. They're looking at, in the front, they were doing 30 meg down and 19 meg up. Moved to the back where there was no contention with the outside LTE, they were doing 60 megabits down and 30 megabits up. People in Korea are not using Wi-Fi, they're using LTE for their small cells.
And just to be clear, that first, that 30 down was actually from the cell tower that was a couple miles away or some distance, right?
That was from a small cell in the building, but that small cell was also contending with the outside. Okay. So they had to turn it down, turn the power down, because they didn't want to overblast the outside. But the one in back, they didn't have to. Okay. And so since there was no contention with the external world, it was flowing at full speed. But that's an LTE. Right now, however, a lot of the carriers in the United States are trying to figure out where we're going to go. Are we going to do in LTE? Are we going to do it on 700? Are we going to do it on AWS? Are we going to do it on PCS? Where exactly is it going to end up? And while they're trying to figure that out, and they're not wasting time, they're just treading water right now, trying to figure out where they're going to anchor in and go. They're getting overloaded on their 3G networks. Putting small cells in you can put them right in the biggest hotspot you've got. If you've got a university campus, put 7 in, cover the entire campus, take everybody off of that network. The thousands of students that are there, all being handled off of maybe 7 small cells. Take and put it in a high school. And now you've got 1 or 2 in there covering the 2,000 students that might be in there at a fraction of the cost of a regular cell site out there. Now, do you say, gee, would you put it in high school? Absolutely you will, because the schools now are starting to use cell phones in their teaching process. And so you've got people wanting to use the service. Now you've got it. Put it in a mall. Again, the problem that most malls are built out of metal type of things, they suck signal. Or put it in a Fleet Farm or a Walgreens. I mean, all of these buildings, these big box stores are built with metal infrastructure, and they basically suck signal. Why not put it inside?
And from a cost standpoint, has it come down to the point where it can be competitive with other technologies?
It has. The core infrastructure is not, at this point, as cheap as you'd like it to be. But we're looking at doing possibly hosting on that so that everybody can share off of that. There are, that solution is out there. So you can take and say, all right, I'm going to let somebody else host it. Then I'll just pay for the film to sell and the service off of it. And then the prices have come down dramatically. Now, for the residential one, they're still a little bit expensive. But for the enterprise one, they're very economical.
And from a backhaul perspective, right, that's the other challenge, isn't it? How do you get that bandwidth back?
Actually, that's the beauty of the small cell, is because it uses the internet. So in the case of a residential one, which is going to run you about $300, $250, $200, somewhere in that area, depending where you're buying it, you're using the person's DSL or cable modem. On the enterprise side of it, if you're putting it into a business or otherwise, you're improving the service within the building for them. Partner with the people that own the building, whether it be an apartment complex or it be the particular business that's there. Go in there and just piggyback on their network. You're using bandwidth through a tunnel, so it's not affecting their network and it's not affecting yours because they're separated in the middle of it. But here's the thing, is that somebody puts in a 10 meg pipe into their business and they're maybe not be using all of that 10 meg. Well, you can pull off 3 meg of that for your small cell. It's a whole lot cheaper than doing it that way by partnering with them than it would be to, let's say, go out and buy your own 3 meg pipe in, because you could add it up to 15 meg at hardly any cost at all from the local cable company or the telephone company, because once you've got that first pipe in, the addition isn't that much.
I suppose one of the other advantages of the LTE is the management of all these devices, right? Because that becomes a big challenge, doesn't it?
Well, actually, no. I mean, between whether it's using 3G or LTE, both of them are going to require what they call SON. And the SON network, or self-optimizing network, allows you then to, from a distance, be able to monitor what's happening and adjust as need be. Each of the cell sites does sniff out its neighbors. It does see the power levels of the neighbors, and so can self-adjust to that. And that's really what you're looking for, is to be able to balance your network out without having to have engineers involved. Now, with the enterprise version, you get the engineers involved initially, but take an example of a high school game. You've got a high school football game. You'll have a couple hundred kids all in one location. Well, why not put a small cell in there? Right now, if we have an event, a county fair or something like that, we'll put in a cow. Which is cell site on wheels. Well, that thing is not cheap, and your backhaul is microwave and everything else you're putting into it. If you can find, the high school usually has connectivity, and at night it's not being used anyhow. So plug in a small cell, plug it into their Ethernet, set up a netting through the network, and you're up and running. And you've now got excellent coverage within that building for the event that's going on. Now, think about that if you take it one step further. Why not have the kids that are watching the game videotape the game for you? You can get a videotape. Matter of fact, the guy I'm talking to right now told me about a camera. You can get a $900 camera that has Wi-Fi built into it. So use the Wi-Fi to talk back to a central point, put in a small caching server, and now people in the game can watch actually on their phone the game as it is from a different angle that they're at. If they're at a high school football game or something, they can watch and see the field goal as it goes through, or afterwards on a replay. And it's not taking my cellular network, it's taking my cellular network on a small cell. So it doesn't even have to leave the field to do it. Yeah. It's kind of a fascinating way to look at it.
Well, and that's also another fascinating thing about that is now you perhaps could get around some of those high school rules that might be in place that prevent maybe broadcasting that game, because you're not really broadcasting, you're keeping it local.
Exactly. It's all staying there. It's only being used in the stadium. The beauty of it is that the high school could, let's say, charge a couple of bucks for it as a service that people could have. Another fundraiser for them, gives them a reason to go to the game as opposed to not. But then you can go beyond that. You could take things like this, using a small cell again in some of the mega churches and stuff like that. Why not send the video out to, let somebody watch the wedding from far away? A lot of intriguing things. And the Connected Home conference that we're at kind of plays into that, gives us a little feel for that. Take a small cell, put it into my house, and with that, then I know whatever phone walked in. Because the cell phone knows who walked in. Now, right now, the issue is that I've got security in my house. Somebody walks in, I get a door trigger and says, somebody walked into my house. Great. Who? Now, if it's my wife, maybe I want to turn the lights on. If it's my friendly burglar, maybe I want to call the cops.
Right.
Well, with a small cell, I know that it was my wife that walked in, or I know that my son Robbie got home. And so I've got a situation where I know who it is. I can trigger it to do different things because I now have identity, which is something I can't get any other way. I'm near-field communications, yeah, but this is already built in.
And it's identity without the user having to do anything. Right.
Exactly, and that's really where you want to get to. We were talking, one of the conferences, meetings I was at here talked about mobile health and healthcare at home. So now you've got a situation where somebody comes home, they're a senior citizen or otherwise, or somebody that's under medical care. They walk into the house, the network knows they're there. They can deal with them differently. They know they've got immediate contact with them. You could even use the phone for the ability to find out if somebody fell down. The phone has that capability in it. Maybe you can tap into that technology, but now you know where they are. You can get that message out. You know that they've fallen down and they can't get up, and they didn't have to do anything to tell them about it.
Yeah, it kind of eliminates the whole PERS service, or changes it anyhow.
It sure does.
Yeah. So now, just to talk about your company role briefly, because you have a very unique footprint, if you will, right? Because you do have some relatively urban areas and then very rural areas. So the challenges of providing LTE to that kind of diversity must be immense.
Well, LTE is kind of an odd duck. We have some 700 licenses, and that's great for traveling from here to wherever. The government is going to be auctioning off the 600 licenses and sometime in the near future, and it really depends on who plays in that arena. It's kind of an odd situation because if you're in rural, you want to be able to cover a large distance with your signal. Well, 600 would be very good for that. We'd love that. The problem is that until we know who's playing there and whether anybody will ever develop a device for it, if there's not a large market for it, we can own the spectrum, but nobody uses it. So it's kind of an odd, do I bid, do I not bid type of thing. And then, of course, if the FCC in their infinite wisdom does what they got talked into doing this last auction, was setting up 1,600 different bands, you know, and I guess that did that around the world, but none of the bands work with each other very well, and so your phones don't work together. So again, unlike PCS where everything worked, or unlike cellular where we only had two different frequencies, or two different technologies, but everything on those technologies work together, now we've got all sorts of different devices that don't talk to each other. So hopefully with the new spectrum auction with the 600, they'll lock in on, this is the band, make it work for you. Don't screw with it, don't play with it. Everybody who has it can use it, and it's open for roaming. If they can do that, that'll help us in the rural area with LTE. The other areas we go into is once we get past the 600 and the 700, of course the 850, but that won't be repurposed for a number of years. So the area, the type of signal that will travel the greatest distance is not necessarily at the moment fully readily available. And then of course the hand devices are not available for it, or the devices aren't. So where do we go from there? Well, then you can go into PCS. But now PCS has about half the distance that it'll travel that an 800 would. And you've also got AWS. And again, that doesn't travel nearly as far. So we're faced with a situation of how do we get that signal out? In my mind, I think the best approach is if you've got the 700, or if you've got something that travels a good long distance, you can deploy that, and that gives you the reach. But you really need to have something underneath it. And even Verizon's doing that because they've been a big play in the AWS. They've got the 700 to give them a big footprint, but then they use AWS, or they're planning on using AWS in the urban areas, give them more frequency, availability, and reuse. We're planning on doing similar type of technology. We're going to be doing something that will cover the big footprint, but then we'll be using the small cells, either in an AWS or a PCS, as a way in which we can now, we're talking LTE because we're using it for both LTE and for CDMA. But we'll use the LTE small cells to cover those dense areas. The beauty of it too is the throughput. If you put in a large antenna that covers a large area, half the distance out, half of the full circle, your data throughput on an LTE might be 7 meg. That's halfway. Anything beyond that halfway is considerably less. Yet right at the core it could be 60. So you can see how much a dramatic drop it is.
Back to that small cell.
Exactly, and as you get really tight, you know, you're talking maybe only about 8% or 1/8 of the signal out, you've dropped down to like 28 meg through. So I mean, the throughput drops off dramatically. The small cell, your throughput is right there. So put that where 70% of the people use it. The other thing that's kind of interesting is that I've got a small cell. If I'm using it on CDMA or I'm using it on UMTS, I've got the full bandwidth for me. I'm not sharing it with other 100 people or 2,000 people under that cell site. They're only me and my kids, or me and the other people in my office. I've got 3 meg right there. That's pretty darn good.
Yeah, and so from a back to the rural thing, do you anticipate serving customers kind of in a not necessarily to their device, but maybe to like a gateway within the home, an LTE gateway or something like that?
It's very much the possibility. It's a couple of different ways that people have done. Rick Virgin up at boy, all of a sudden I can't think of where Rick's company is. In Wisconsin, yeah. Anyhow, he's, I'm going to keep going all night thinking about that. But anyhow, Rick's company, what they're using is using 700 as a backhaul. And they're putting AWS small cells in to the residences. And the customers where they have poor service, they love it. It's absolutely perfect for them. But, so that's one way you can go with it. I've talked in the past about if we can get the LTE small cell economically enough and hardened, and right now they're just coming out with them, so I don't know where that's going to be. But why not take, if you've got a fiber running down a highway, why not take and pop that up at every pedestal, and now you could do the last mile drop, so you don't have to put any coax or, for that matter, copper or fiber into the house. You could simply have this as your connection to LTE to the house. Now, that means you're both the telephone company and the cellular company. Not everybody's in that situation. We happen to have that, but our landline is a whole lot smaller than our cellular footprint.
Well, that could be significant because sometimes if you have to a mile or so to that farmhouse, right, if you can eliminate that drop, that's a big cost savings, right?
Oh, it is. It's huge. It's huge. And if you think about if I've got that kind of throughput, I mean, that's the toughest thing with LTE small cells in the residence as an example, is it's great that I can do 60 meg, but do I have a 60 meg pipe? Unless I've got a really good cable connection, but I'm sharing that with my neighbors too, I probably have 30 meg. Right. Or if you're like me and I've got a microwave link to the house, well, then I'm okay. Not everybody has that.
Yeah, so it sounds like there's still it's still evolving, but you guys are still a big part of it. So, Rob, I appreciate you being here with us.
Thank you very much. Appreciate it.